Hello? Hello? Am I audible? Okay. Welcome back, all the participants. Uh, Welcome back, all the participants. So, we are going to discuss now about the one of the very important simulator, Yuva Pedova. Okay, means in our research group, we are working on a diabetes disease from I think past 4 5 years. Okay, and from past 2 years, we have started about the diabetes management. Okay, and if you want to work in a research field of diabetes management, then this is the simulator which is currently a benchmark. Okay, because all the result you will observe in a UA Pedava simulator only. Okay, and that is actually we have also uh, consider over here for the point of discussion. We will see demonstration also that how you can use a UA Pedava simulator. So we will discuss briefly about the diabetes, then what are the way of the measurement of the blood glucose, then role of the pancreas, then we will talk about in silico artificial pancreas because that is very much important to understand the UA Pedava simulator. Okay, and then we will see the programming sum up. Diabetes possibly we have discussed a lot. Okay, but still those means who are not aware, for them that it is a chronic metabolic disease in which body is either does not produce enough insulin, so that is type 2 diabetes, and cannot effectively use the insulin for it produces. So if there is no insulin is being produced, then it is type 1 diabetes, and if there is some amount of the insulin is being produced, then it is type 2 diabetes. Okay, type 1 diabetes is more dangerous because where the insulin is not being generated at all. So because of this, the body cannot properly regulate the level of the glucose in the body blood. Okay, because whatever the food item that is being consumed, that is generating a glucagon, and that ultimately through a liver, basically glucose is being contributed in a blood cell. But there is no insulin to actually means neutralize that additional glucose. So type 1 diabetes is ultimately autoimmune destruction of the insulin producing beta cell in a pancreas, requiring lifelong insulin therapy. So here your body is not reacting any about your glucose. That means there is no insulin is being produced inside your pancreas. Then it is type 1 diabetes. So for them, the insulin has to be inserted inside the body externally. ठीक है. Type 2 diabetes, when body has become resistant to the insulin but it doesn't make enough, so there is not adequate insulin which is being generated inside the pancreas so that it can neutralize the excess amount of the glucose value. So often linked with the obesity, sedentary lifestyle and genetics. Gestational diabetes is basically developed during the pregnancy of the woman, and that is a temporary diabetes, and that has an increased risk for a woman to enter into the type 2 diabetes. Symptoms of the diabetes, that possibly the thirst will be observed very frequently. There is a some sort of slow healing of cuts and sores. There is a some sort of fatigueness, your vision problem, your frequent urination, and unexpected weight loss. When we talk about the blood glucose, then blood glucose are of two type. Okay, possibly we discussed that. Capillary glucose. Capillary glucose is a glucose which is being measured from a whole blood sample. Okay, so whatever the self monitoring device that we used to purchase. Okay, so over there we used to have a whole blood sample, and through which we are identifying the glucose value. Okay, so that is a capillary glucose. Another is a venous plasma, or in more popular it is considered a serum blood test. Okay, so from where the blood sample is being captured from your body, then from that blood sample all the heavy particle is being removed. Okay, and the only a particle which will looks like a water, okay, that is basically used for the glucose measurement purpose. So that is the serum glucose. So for a frequent measurement of the blood glucose, it is not feasible to use the invasive method to measure the blood glucose sugar level. Okay, so invasive method. Now, ultimately, for a type 1 diabetes, the insulin consumption is a very much essential. Okay, so for insulin consumption, ultimately, we would like to have measurement of the blood glucose, because what is the quantity of the insulin that you need to consume, that often derive from a whatever the present blood glucose value. Okay, currently, means most of the time what people used to take, they used to take the insulin injection before having a food item. Okay, if you observe any type 1 diabetes patient, so type 1 diabetes patient, what they used to do, they used to, means take the insulin injection of a predefined dose before having the food. At that time, they are not aware about what is their current blood glucose value. Okay, it could be sometime dangerous. Okay, because if your blood glucose is always in a control, if your blood glucose is somewhat in your control limit and you take a insulin, then you may enter into the hypoglycemia state. Okay, and hypoglycemia state is a very much dangerous for any kind of patient. Okay, so at that time you can lose your control of your mind. Okay, so that's why the continuous monitoring is required. So for a continuous monitoring, the non-invasive measurement is very much important. And most of the time when we talk about non-invasive measurement, then they are basically optical methods. Okay, so where light is being incident on your fingertip and you are trying to observe the intensity variation in the light, and that intensity variation of the light is basically related to your blood glucose concentration. Okay, so optical method is basically used to measure the blood glucose, typically user infrared range spectroscopy, to analyze how light is being absorbed or scattered by a glucose molecule in the skin and the blood. This non-invasive technique directs the NIR light into the tissue and measure the resulting light. That is basically what I am talking about, the that light intensity variation, which is being affected by a glucose concentration. So it is something like that, that if whatever the light source that is basically uh, sensitive towards the glucose particle, or that glucose particle is sensitive towards the light source, then whenever that particular light source will be imparted onto a glucose particle, then that glucose particle may observe or absorb that particular light. Okay, so if that light is being absorbed by a glucose particle, then there will be definitely the intensity variation which is being observed at the receiver end. Okay, and that intensity variation whatever is being observed, that actually help us to get the prediction of the blood glucose value. So this is nothing but the setup. Okay, so through one sensor we have actually developed a non-invasive glucometer. So whatever like iGlue, so that is updated version, where means we have put only one sensor. Okay, initially we started with a 3 sensor in a iGlue, then with the 940 only we have used that. Okay, and iGlue is now meter oxygen saturation, then it is being converted into to digital form, and then the data is being plugged into the machine learning model, and the regression, basically the model is applicable over here because you want to predict a glucose value or your SpO2 value. Okay, so which is a continuous value, which is a continuous variable. Okay, so for that the regression model is being used, and then you will get the output. Okay, now pancreas role is very much important in your diabetes. Okay, so means if you are not a diabetic patient, then your pancreas is working very fine, very well. Okay, There is nothing wrong with your pancreas. That's why you are surviving the case of the diabetes. Now, pancreas is an organ which is located in the abdomen behind your stomach. The pancreas has a basically two main functionality. One is a exocrine function, which actually helping for the digestion of the your food consumption item, and endocrine function, which regulates the blood sugar, Okay, so pancreas is basically playing a very important role, and inside the pancreas there are various kind of cell are there. Okay, Echiner cell, capillary, alpha, beta, delta, F cell. But for us, the two important cell is alpha cell and beta cell. Alpha cell is responsible for a glucagon. That glucagon hormone is contributing towards the glucose generation inside your blood cell. Okay, and the beta cell of the pancreas is responsible for a insulin generation. Okay, so if your you are entered into the diabetic condition, that means your beta cell functionality has been somewhat compromised. It is not functioning properly. That beta cell supposed to generate the insulin. It is something like that, that if I am non-diabetic, even though I am taking a good sweet item, okay, then glucose definitely higher at that particular time during the consumption of the any particular sweet item. But my pancreas is good enough to generate the appropriate insulin through a beta cell, so that their means value will be compromised. Okay, that's why the alpha and beta cell role is very important. So what is beta cell? Beta cells are those cells that actually help us to secrete the insulin. Insulin is a hormone that controls the blood glucose level, because as I said that it will help to neutralize the value. Alpha cell is basically secrete the glucagon in order to increase the glucose level. See, glucose is very important. I said in one of the lecture, glucose is very much important. There is no problem with the glucose generation. There is a problem with the insulin generation, because glucose is required in your body to perform all your daily activity. If you are not having enough glucose in your blood cell, then your brain will not work properly. So that is I consider as a hypoglycemia. Okay, so that's why beta cell. Okay, so beta cell is basically, you can consider that contributing towards the insulin generation inside your pancreas. Okay, so pancreas में आपके डिफरेंट सेल्स होते हैं, उसमें जो बीटा सेल होते हैं वो आपके इंसुलिन जनरेशन में कंट्रीब्यूट करते हैं. ठीक है, और वो ऑटोमेटिक होता है. ठीक है, वो एडेप्टिवली चेंज होता है बीटा सेल का इंसुलिन जनरेशन प्रोसेस. अगर आपने कुछ स्वीट खाया है और आपका मीन्स पेंक्रियास में अभी बहुत सारा ग्लूकोज है, तो वो ग्लूकोज को न्यूट्रलाइज करने के लिए आपका पेंक्रियास ऑटोमेटिकली बीटा सेल को एक्टिवेट करता है और आपका इंसुलिन ज्यादा जनरेट होगा, क्योंकि आपका प्रेजेंटली जो पेंक्रियास है उसमें ग्लूकोगॉन ज्यादा है. दैट मीन्स कि अल्फा सेल की, अगर अल्फा सेल ज्यादा एक्टिव है तो आपका बीटा सेल भी उसके इक्विवेलेंट एक्टिव होने चाहिए, सो दैट अल्फा और बीटा का आपका लेवल बैलेंस बना रहे. एंड अल्टीमेटली अल्फा एंड बीटा सेल is nothing but glucose insulin balance. Okay, so glucose insulin balance is very much important, and in order to do that the beta cell will play a crucial role. See, in our body there is no problem with the alpha cell. अगर alpha cell में problem हो गया, then almost means your body functionality will not be performed. Okay, because your body movement is basically that energy comes from your alpha cell. Okay, however the excessive amount of the glucagon is a problem, and for that the beta cell is there, so that I can make a balance of the glucose. So in presence of the glycagon which is stored in a liver gets converted into the glucose. So that whatever the glucagon hormone is there, through a liver it is being generated in a converted into the glucose. If your blood glucose gets low, the glucagon helps to raise it by sending a message to the liver to release the stored sugar. Okay, so this is an automatic cycle which occurs inside our body. Okay, so this is just a pictorial view that whatever the glucagon hormone is there, that goes into the liver, and then basically it will generate the glucose, and that glucose particle is very much important in your blood cell. Okay, because we are considering the blood is being regulated at every part of the body through our heart, and inside that blood the presence of the glucose is very much important in order to get the proper functionality of that particular body part. So now we will talk about the pancreas. Okay. Now pancreas maintain the blood glucose value. Now we know that if there is an excess amount of the glucose inside the body, then that we consider as a hyperglycemia. Okay. So in the literature, it is being considered that if value is 150 mg per dl, greater than 150 mg per dl, then we consider as a hyperglycemia. Okay. So if your body blood glucose value is greater than 150 at any point of time in your body, then it is considered to be a hyperglycemia. So when there is a hyperglycemia case, at that time we need to think about the insulin generation, or we need to think about the proper functionality of the beta cell. If it is a normal range 70 to 150, there is no problem. If there is less than 70, then we need to think about the alpha cell, because the glucose is not proper inside our body. Okay, so if greater than 150, then we need to think about the beta cell. So hyperglycemia is a condition when the blood glucose value is low or blood glucose value is high, and hypoglycemia is a condition where blood glucose value is low. Now we are interested to understand the artificial pancreas. Okay, now we have seen the role of the pancreas. What is the role of the pancreas? Basically to neutralize the glucose and insulin balance. Now if that glucose insulin balance is not happening inside our own pancreas, then there is a need of having a artificial pancreas. So this we consider as a APS mechanism, artificial pancreas system. Okay, so in an artificial pancreas system, what would we have? We would have some sort of insulin pump. Inside that insulin pump, there is some sort of mathematical model is there. That mathematical model will decide that what amount of the insulin should be injected inside your body. And once it is being injected inside the body, then it will go into your blood cell, and it will help to neutralize the excess amount of the glucose which is present in our blood cell. So artificial pancreas is nothing but a device or system which is being integrated device which substitute an endocrine pancreas. So if your pancreas is not working properly, then we are having a artificial pancreas which actually help us to supply those functionality which is not being provided by your own pancreas. So it senses the blood glucose level, it determines the amount of the insulin needed, and then deliver the appropriate amount of the insulin. Okay, so ultimately what is the role of the insulin pump? To release the insulin inside the body, but that insulin concentration is being identified by according to whatever the current blood glucose value. Okay, so we have developed our iGlu, which is a non-invasive glucometer, intelligent glucometer, which actually help us to continuously measure the blood glucose value. Now that blood glucose value is continuously being measured, and that is being provided as an input to your artificial pancreas. Now artificial pancreas has a knowledge of what is your current blood glucose value. According to that, the insulin is being identified, at what amount of the insulin is to be provided to your body, and then appropriate insulin is being injected inside the body. Okay, now we are trying to understand the UVA Padova simulator. So UVA Padova simulator is nothing but we consider as a having a in silico T1DM model. Now what do you mean by in silico? In silico is something which you will perform at the simulation level. ओके, जैसे कि इन विट्रो, इन विवो, वैसे इन सिलिको. इन सिलिको इज नथिंग बट विच एक्चुअली यू कैन डू इन सिमुलेट, एंड you can run it on a computer and generate some sort of prediction or estimation out of it. Then we consider as a in silico. So in silico, T1DM. T1 that means type 1, DM stands for diabetes mellitus. Okay, diabetes का actual scientific name है diabetes mellitus. Okay, so DM. So in silico T1 DM model. So that is applicable for our UA PEDAWA simulator. So here the amount of the insulin required is not constant throughout the day. Even it vary from the subject to subject. So means our glucose level is changing throughout the day. So according to the glucose level, whatever the insulin has to be generated, that has to be also changed throughout the day. Okay. So even for a particular subject, over the period of time, the insulin level is different because their glucose level is different. So we also are being observed that if I want to actually go for a glucose test, then I will go for it 2 times in a day. First, before having any particular food, and then after a food, after maybe 1 hour, 1.5 hours or 2 hours. So that is the window at which I am basically measuring the glucose level. It also varies from subject to subject. So subject to subject also it is different. This is known as a insulin time varying nature. Therefore, the whatever the simulator model which has to be developed, it should mimic this performance and it should takes into account the insulin's intra-subject and inter-subject variability. ठीक है? So intra-subject within a particular patient's body, also the insulin variation has to be there because after taking a meal, maybe your glucose value is high. So insulin requirement is high. But maybe after 4 or 5 hours of a meal, if you measure the glucose level, then it is low. Then definitely means the insulin requirement at that time is a different. So intra-subject as well as the inter-subject. Inter-subject variability will be definitely there according to the age, according to the weight. So there are so many parameters which actually contributes towards the developing the glucose level inside the body. So the subject exhibit the greater insulin sensitivity at the dinner compared to at the lunch and the breakfast. Okay, so this is our human tendency that we used to have a heavy dinner. Okay, then compared to lunch and break. So that's why the insulin sensitivity is higher at the dinner time than your lunch and the breakfast. This is in silicon artificial pancreas board. Okay, so that is we have taken from that manual itself. Okay, so ultimately this is basically in silico subject simulator is there. Okay, here we have a silicon sensor. Okay. Then we have a controller, and this controller is being connected with the insulin pump. Okay, now what is the role of the controller? Controller will actually send the command to insulin pump, and according to the command it will release the insulin inside the body. Okay, so it is something like that insulin pump. So insulin pump is having a one controller. That controller is basically controlling the functionality of the insulin. Okay, so controller will send the command, then insulin will inject the insulin inside the body. Now concentration depends upon how long you are providing the insulin inside the body. Okay, so that is basically governed through a controller, and that controller is basically taking the value from a sensor. So this sensor could be your glucose sensor. That glucose sensor will provide the value. Now if it is within the range, then no need to have any command from your controller to a insulin pump. But if your glucose value is higher, then controller will control the insulin pump in a way that sending the command. So it will send the command because your glucose value is high. You are currently in a hyperglycemia state. So you want to ensure that it should be in a normal range. Okay. So until the glucose being measured by a glucose sensor as a normal range, the command is continuously sending to an insulin pump to release the insulin inside the body. As soon as the glucose sensor detect the glucose value within the range, the controller send the command. But since now, if you observe that the glucose sensor is observing the normal range reading, then the controller stops sending the command and your insulin injection inside the body stops. So various model parameter that we need to understand while you are actually dealing with the UA Padova simulator. Okay. So carbohydrate to insulin ratio is very important. How carbohydrate is being generated? Carbohydrate is whatever the amount of the food item that you are consuming. Okay. So whatever the food item that you consuming, that actually contributing towards the carbohydrate intake inside your body. And according to whatever the carbohydrate which is being generated, that actually signifies your glucose inside your body, and that has to be governed through a proper insulin generation inside the body. So carbohydrate to insulin ratio is important. The correction factor is also very important. So we are going to see that what is the actually the formula to calculate this carbohydrate to insulin ratio and the correction factor. So these two are the key parameter that will vary between the individual over a period of time. The mean value of the carbohydrate to insulin ratio for children, adults, and your adults is different. Now, if you just observe it, for the children, your CR ratio is higher. Okay, for the children, definitely the requirement of, or insulin generation of the body is lesser. Okay, so that's why that carbohydrate to insulin ratio is slightly higher. Adult set is basically the age group of 11 to 20. Okay, so for them slightly means lower, and for the adults you can consider it is a lowest, it is 15.9. So this is actually the value which is being observed in a literature, and that is being considered most of the time in a literature. So it means that when a children, adult set and adult receive the same and equal amount of the food in proportion to their body weight, the amount of the insulin required to dissolve the glucose by a blood cell is less in children in compared to adults and adults. ठीक है? So the correlation factor in a children is also more than that in a adult set and adults. Because of this, children shows higher insulin sensitivity and the lower body weight. Okay. So whatever the UA Padova simulator is there, over there are 33 subjects are there. So virtually subjects data is available inside the simulator. So 10 is for children, 10 is for adult set, and 10 is for adults. Okay. And remaining 3 value is considered the average value of all 10. Okay. So all 10 adult is one average value, adult set is one average value, and the children one average value. So that way, total 33 in silico subjects values are available in your simulator. This is basically your carbohydrate to insulin ratio factor. So amount of the carbohydrate ingested divided by bolus dose of insulin. Now what is bolus dose? Bolus dose is nothing but you can consider insulin which is being provided at the time of the fasting. Okay. So as I said that type 1 diabetes is used to take a insulin injection. So that insulin injection is having a one particular dose. Okay. So that is nothing but a bolus dose of the insulin that we are considering. So basically your carbohydrate to insulin factor is nothing but a carbohydrate intake divided by the bolus dose of the insulin. Your correction factor. So correction factor is 1700 divided by TDI. So total daily insulin. Okay. So what amount of the total daily insulin is there? That is your TDI. And 1700 is basically comes with the literature. That is the average value of you can consider that inside the body of a balance value of the glucose and insulin inside a particular person body is being considered. Okay, so that is a fix. Sometime it is considered 1800, sometime 1700, but it is in this range only. Okay, 17 or 1800 range. Okay, and what is the bolus dose of insulin? It is basically a current blood glucose value minus targeted blood glucose value divided by CF. That is a correction factor. So what is my current blood glucose value and what is my target? So it is something like that. My current blood glucose value is 180 and I am targeting that it should be go to 120. Okay. So I need to lower down my glucose value from 180 to 120. Now for that, what is your insulin dose has to be provided. That actually comes with the this particular formula. Okay, so insulin resistance insulin resistance in the body is basically very much important. The body cell don't respond normally to the insulin. Glucose cannot enter the cell as easily as it should be, so it builds up in the blood. So blood glucose, that's why we used to term that a blood glucose value. Okay, so this can eventually lead to a type 2 diabetes. So insulin resistance typically has no symptoms. Okay, basals and bolus. So basal dose is nothing but uh, the insulin which is being generated naturally inside the body, which is being generated continuously by a body. So that we consider as a basal dose. Okay, and bolus is whatever is being injected artificially outside the body. Okay, so that is some sort of artificial insulin that we consider. Okay, so that is basal and bolus dole. Now this is basically a GUI that we are going to see in a basically next 15-20 minutes. Okay, that this is the main graphical user interface of UA Pedava simulator. Now this UA Pedava simulator is to be integrated in your MATLAB. Okay, and this UA Pedova simulator is not a free version. Okay, it is having some nominal price of around 10,000 to 12,000. Okay, that we have purchased in a one particular project. So this particular simulator is being developed by University of Virginia, Padova University, and Epsilon Group. So they have developed a one particular simulator which actually help us to get the generation of the artificial pancreas. Okay, so over here this simulator is a part of the your MATLAB. Okay, and as I said that it requires some sort of license version. Okay, so here you have a simulator. Now in this simulator you can select a different scenario. Okay, so there are inbuilt scenario which are available, and you can select that particular scenario for your simulation. Otherwise there is a way that you can create your own scenario also. So in own scenario, that means what is your food intake, at what amount of the time you are taking a food. Okay, so all this is basically available in your generation of the scenario. So you can select your all available scenario which is there by default inside the simulator, or there is a way that you can create your own scenario as well. Okay, that scenario you need to select and you need to add it on your right window. So currently there is no scenario which is being selected. That's why it is seen a red color. If you just observe over here, at two left corner, there is a red color. So when there is no scenario is being selected, then it is a red color. When a particular scenario is being selected by a user, then it will be converted into the green. Okay. So first one is for the scenario and second one is for a subject. So similarly, you need to create a subject according to the scenario as well. Okay. Here you will just observe the hardware. That sensor. Sensor is IV, SMBG or CGM. So IV, it in intravascular, that is basically your serum glucose that basically comes from a laboratory. Okay, so if that value, that sensor is available and that glucose value is available, then you need to select this. SMBG, self monitoring blood glucose. So that is which is available in the market that we use at our home. Okay, where we used to have a strip and a launching pad, and through which we use a whole blood glucose sample to measure the glucose value. So that is SMBG. CGM. CGM is a continuous glucose monitoring which is currently available. Is a one company is a Cogna which basically provide you a patch. Okay, which you need to actually insert it inside your means body part. Okay, and through it in a mobile app you can get the continuous glucose value. So that patch is basically applicable for a 15-20 days. After that you need to replace that particular patch. Okay, so that is a CGM. So you can select any particular scenario and purpose, that is generic, no generic, no. So that is possibly we will see at the time of the. Now here how you can generate your own scenario. So here the scenario name you can given. So here basically that we have given a template. Then simulation parameter. So this you can change it while you are creating your own scenario. See, if you have selected by default scenario, then by default parameter will come. Okay. However, you can change those parameter. Okay. But when you are clear that you need to create your own scenario. So for that, every value you need to put it by your own. So length of the simulation in minutes. So here it is 1440. So what is this? This is for a 1 day. Okay. So 24 hours multiplied by 60. If you do it, then it will comes out 1440. So that is for a 1 day. Okay. Start of the time. So start of the time usually means time cycle runs from a midnight 12 to a next day 12. Okay. So 12 o'clock at the midnight, I am considering a zero time clock. Then 1 hour is 1 night PM, 7 hour is morning 7, like that. Okay. So that parameter you can enter amount of the carbohydrate intake through a single meal. Okay. So if you know that what amount of the carbohydrate is being intake by a present meal, then you can provide over here. Or there is a option of a multiple meal. Now multiple meal have a total 5 options. So it is being considered that usually you take a particular food item 5 times in a day. So maybe at the morning, at the breakfast, that we consider as a 7 a.m. Then we consider as a lunch, which is at the noon. Then we consider as a snack, which we consume at the 4 p.m. Then we have a dinner, which is at the 6 p.m. and the snacks, which is at the 11 p.m. So this carbs value is being considered as an input. So that you can provide it. Okay. So how you can get it? Most of the time, maybe you can means calculate it with some sort of intelligent app. Otherwise, if you are consuming some packed food, then you know what is the amount of the carbohydrate intake is that. So that carbohydrate intake value need to supply it over here. Okay. Then you need to means write down what is your means controlling parameter, means what is your range. Okay. So what is your control range of the blood glucose? So here we have considered 70 to 180 mb per dl. So that also you can decide 70 to 120, maybe 100 to 120, according to your wish. What is your range of the blood glucose you want for a glucose insulin balance? Okay. So what is the benefits and challenges for this in silico simulator? Computer simulation can provide invaluable information about the safety and limitation of the closed loop control algorithm. It can guide and focus the emphasis on the clinical study and can outrun the ineffective control scenario. So it can help us with the in silicon. We can actually avoid the animal trials and we can prove our hypothesis. Okay, and then we can jump towards the vivo kind of testing directly. It is time and cost saving also. The computer simulation is very a good way to actually check your hypothesis through a model. So that's why this in silico simulation of the UA Padova is very much important. Okay. So with this, we are ending up our this particular session. Now we are going for a demonstration. Okay. So we are just ending this particular session and we are starting our next session maybe in next 10 minutes. Okay. So maybe at 12:05 we are starting a UA Padova simulation. Okay. So for that, because the means your license is at our laboratory. So one of my PhD students, Shraddhanand, will demonstrate the UA Padova simulator over there. Okay. So we will start at 12:05 because Shraddhanand is also over here. He is managing this particular means meeting as well. So he will stop the meeting and he will go to a laboratory. So maybe it will take around 20 minutes. So after 20 minutes, we will start our means simulation of a UA Padova. So you will have a hands-on session. Okay. So thank you. See you at 12:05. ठीक है सर, done.